Now on to section 3.3. We are skipping 3.2. Hopefully this is going to be a quick and understandable lesson. The whole concept here is, something we already know. If the derivative is positive, that means the slope is positive, which means the function must be increasing. Vice versa for if the derivative is negative. So these two statements below should be pretty obvious. A function's increasing if the first derivative is positive. And then a function is decreasing if the first derivative is negative. What we're going to be mostly concerned now is this point that it changes. And you can see this point is a high point on that graph if it goes from increasing to decreasing. And if it goes from decreasing to increasing, that's going to be a low point. As you're going to see, this is going to be called a relative maximum because it's the highest point relative to the points around it. And this is going to be called a relative minimum. Now, it's relative because if the graph looks like this, it can have a bunch of relative maximums and also a bunch of relative minimums. So here we go. Relative maximum and minimums are also called, if you want to use just one single word for relative extreme values. When a graph goes from increasing to decreasing, that's a relative minimum, as we just showed. And if the graph goes from decreasing to increasing, it's a relative minimum. Now we're going to talk in terms of derivatives. So when we say increasing, we're going to say f prime is positive. And when we say decreasing, we're just going to say f prime is negative. F prime is negative. So we've talked about critical numbers, and we know that's where the derivative is 0. So that's going to be an important point here because the derivative is neither negative nor positive there. If the derivative changes at a critical number, say from positive or negative to positive, then we have a relative minimum right here. The derivative negative to derivative positive. The critical number is where a relative minimum occurs, and vice versa if the derivative goes from positive to negative. Then it would be a relative maximum. So that's all of this, and that should be pretty obvious. It is possible, though, if you find a critical number, that the derivative doesn't change signs. Those would be graphs that look like this and this. If it goes from positive to positive, obviously this is not a relative minimum or maximum. It's just a point. Same thing if it goes from negative to negative. So that's just saying that just because you have a critical number, it doesn't mean you need to have a relative extrema. However, and this is very important, if you do have a relative min or max, that must occur at a critical number. So this is the important part of this theorem, just the title. Relative extrema can only occur at critical numbers. So your skill of finding critical numbers from the last section is going to be very important. Now I'm going to stop this video here. So if you need to look back at anything, you can. And then the next video, which is right after this, is going to be actually finding these relative mins and maxes.